Hello, class. Well, we are about to finish the first week of this semester. Since that today is almost Friday, and we are really close to start a second week, I just want to make this video, to check where we should be. Okay, so we're supposed to cover this week, besides all the additional material that you need to cover in your STAR module, we're supposed to cover sections 2.1, 2.2, and 2.3 from chapter number 2 from your textbook, which is about theory of sets. Okay, and basically these three sections, what it's telling to you is all about the fundamental definitions for sets, properties, and start playing with different type of operations that you may start doing with sets. Since that we are going to complement at the very beginning of the second week, which is for section 2.4 and 2.5, that are the last, which are the last two sections of this chapter. So what I'm showing here is your interactive textbook. I just went to our MyLabMap course, and I display your textbook, but instead of using the first option, what I'm displaying here is this second option, which is the interactive part. And at the end of sections 2.3, there are some exercise about these sections. It's like a compilations of exercise that have to do basically with the first three sections, 2.1, 2.2, and 2.3. So that is something that you can find in your textbook. And actually this is very similar to some of the exercise that I left in your lecture, in the lecture for this chapter number 2. So I just want to closing this part of this three section, I just want to go through and to comment some of things. For instance, in here you have a bunch of exercise that says, well, describe a universal set U that includes all the elements of the given sets, and then answer the questions that you have over there. So let me go through some of this. For instance, this exercise. In this exercise, you have the universal set are all the whole numbers, and I'm talking about the whole numbers because this collection doesn't include the zero. Otherwise, we were talking about the natural numbers. But we have all the whole numbers. Let me just click here. From 1 to 20, that is the universal set. I mean, all the numbers that you can count starting in 1 all the way down to 20. Okay, that is the universal set. And from there, we are considering some sets like A, B, C, and D. So, for instance, you can see that A is the collection of the first 5, 1, 2, 3, 4, and 5. B is the collection of the continuous after 5 all the way down to 9, 6, 7, 8, 9. For instance, if I want to say something about A, let's say, okay, what is the cardinality of A? Remember, the cardinality is the number of elements that are not repeated in the set. So we have 1, 2, 3, 4, 5. We have 5 elements. And in here, in B, we have elements from 6 to 9. So we have 4, right? 6, 7, 8, and 9, 4 different elements. What is C? As you can see, C look at here is 1, 3, 5, 7. The next one, if you take into account, what are the ones that I'm taking in C? All the odd numbers within this list. 1, 3, 5, 7. Who's going to be the next one? 9. And after 9, 11, 13, 15, and so on, all the way down to 19. So C is basically, this is the roster notation, but another way to identify C or define C is all the elements that are between 1 and 20, but they are odd numbers. This is C. And D is basically, you can see 2, 4, 6, 8. What is going to be the next one? 10, 12, 14, 16, 18, and 20. I mean, all the even numbers within this list, right? So this is the roster notation. So, for instance, if they say, okay, use the roster notation or the roster notation to write each one of these. The complement of A. What is the complement of A? Well, are all these numbers in this list that are greater than 5. So in the roster notation, what we're going to have? We're going to have 6, 7, 9, 8, 6, 7, 9, 6, 7, 8, 9, 10, 11, all blah, 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 all the way down to 10, to 20. Okay, so that is going to be a complement. I don't know if I have something that allows me to write down in here. Let me see. In here, click here too. Okay, now let me just to iconize this here. I'm supposed to have a pencil here, but I don't see it. I don't know how to retrieve that. But anyway, so let me go to another one. Well, that is a comment about this. Let me go with one in which we can see the Venn diagram representation. For instance, here we have the universal set that are all these elements plus A and 9. But also we have two sets, A and B, that they have some intersection. The intersection is this overshadow here, that is 3 and 7. So for instance, if they are asking us about the intersection, well, is 3 and 7. If they are asking for the union, well, is 1, 4, 3, 7, 2, 5, and 6. Okay, one of the things that we are going to detail next week are the Morgan's law in order to compute the complement of intersections and complement of unions. Okay, so I will provide you with what are those laws that allows you to make this operation. But from here it's very easy to get that. Okay, so for instance, if we are talking about the complement of the intersection of A and B, so using the Venn diagram is very easy to see what are the complements, no? I mean, the complement of the intersection are all the elements that doesn't belong to the intersection. So the intersection is 3 and 7. What is the complement? Well, the complement is 1, 4, 2, 5, 6, and A, 9. Okay, A9, so we need to take into account this one as well. For instance, here, what is the complement of the union? What is the complement of the union? Well, the complement of the union, well, the union is all of these. What is the complement? Well, whatever is in the universal set that is not in the union, which is A and 9. Okay, let me just to make one more. The A complement, all what is in B, and at the same time at the complement of A. What is the complement of A? the complement of A is 2, 5, 6, 8, and 9. And the intersection with B is going to be, well, this part over here, 2, 5, and 6. So that's why the Venn diagrams are very convenient, because it's a graphical representation of the sets, right, that allows you to visualize very easily what are the corresponding complements and what are the corresponding intersections, and also what are the corresponding union and intersection with sets and complements of sets. So that is something that I want to reinforce here in this video. The difference from this one and the next one is that in this one, even though it's quite similar to this, they are asking about the cardinality. Okay, so for instance, in here, let me just to reinforce the cardinality of the union. Well, what is the union of A and B? The union of A and B is all these elements. So in the Venn diagram, we can see that the cardinality is 1, 2, 3, 4, 5, and 6. Now, if you apply the formula of the cardinality of the union, if the cardinality of A, which is 3, plus the cardinality of B, which is 3, minus the cardinality of the intersection, which is 1. So 3, I'm sorry, let me say it again. The cardinality of A, which is 3, the cardinality of B, which is 4, minus the cardinality of the intersection. So 3 plus 4 is 7, minus 1, which is 6. And we have the cardinality of the union, 1, 2, 3, 4, 5, and 6. And the reason that we need to remove the cardinality of the intersection in that formula is because when we count the cardinality of A and the cardinality of B, okay, we are counting the cardinality of the intersection twice. So we need to remove that when we are going to account for the cardinality of the union. Okay, well, this is just a comment that I want to make about these 3 sections. So let me go to our D2L. If you go to our module, and in my lecture, that is at the very beginning of that module, those are the exercises that are left over here. So you see that I have some checkpoint exercise. Well, some of them are pretty similar to the one that we were discussing. So like this one in here, and let me go a little bit further in the lecture. Those one that I have over here, okay? And actually the ones that I just commented a few minutes ago is very similar to this one. And this is the other one that have to do with the cardinalities. So you are more than welcome to try to check some of these exercises. If you check one of them and you find any issue or trouble, just let me know. Whatever we're going to cover next week is going to be section 2.4 and 2.5, have to do with the Morgan's law. That's what I told you. This is another way how to compute the complement of intersection and complement of union by using the Morgan's law. But that is something that we're going to cover next week. And then to close this chapter, we are going to see operation with 3 sets. But that is section 2.4 and 2.5. Well, this is what I want to comment in this video, guys. Okay, thank you.